Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the knapsack problem using greedy method in the syllabus design and analysis of algorithms. Let's get started. So what is knapsack? So the knapsack problem states that when you have a backpack with a weight limit and you are in a room full of treasures, then each treasure will have a value under weight W. So how would you able to solve this? To solve this knapsack problem, you must figure out which treasure to pack to maximize the total value and at the same time keeping below the backpack's weight limit. So this is your backpack problems thing. How would you able to solve the knapsack problem manually? So how to solve? Solving the knapsack problem helps businesses decide which projects to fund within a budget, maximizing profit without overspending. It is also used in logistics to optimize the loading of goods into trucks and planes, ensuring the most valuable or highest prioritized items are included without excluding the weight limits. So let us see the approach. The rules of this knapsack problem, the rules that is, every item will have a weight and a value. Your knapsack will have a weight limit, that is your backpack will have a weight limit. Choose which items you have to bring with you in the knapsack to maximize the profit. You can either take an item or not. You cannot take half of an item, for example in 0/1 knapsack, but half of the item can be taken in the fractional knapsack problem. So goal, we have to maximize the total value of the items in the knapsack. So let us see the first what is mean by an optimization problem. So an optimization problem is, given a problem of instance, we will have a set of constraints and the objective function. For this instance, we have to find a feasible solution and it should be either maximum or minimum depending on the problem being solved. So this will give an optimization problem, either maximum optimal or the minimum optimal. So for some optimization problems, we can either use dynamic program, which is defined as overkill method, or the simpler and the more efficient method is the greedy strategy. So let's see what is the difference between the dynamic programming and the greedy algorithm. So in dynamic programming, at each step, the choice is determined based on the solutions of subproblems. Whereas in greedy approach, at each step, we quickly make a choice that currently looks the best. A local optimum greedy choice is made. Subproblems are solved first, and in greedy choice can be made first before solving further subproblems. Dynamic programming allows bottom-up approach, whereas greedy algorithm uses top-down approach. When we compare, dynamic programs are slower and are more complex in nature, whereas greedy algorithms are usually faster and simpler to use. Greedy method. So let us see the characteristics of the greedy method. So in the greedy algorithm, it makes a sequence of choices, and each choice is the one that seems the best so far or at the level, and then depends on what's been done so far. So the choices produces a problem, so smaller problems to be solved. So the phases of greedy algorithm. The greedy algorithm works in different phases. At each phase, it takes the best solution at that time right now without considering the future consequences. It chooses a local optimum at each step, either a maximum optimum or the minimum optimum at each step, and end up at a global optimum solution. So let's see the knapsack problem. So there are two versions of knapsack problem, 0/1 knapsack. So here items are indivisible, that is we cannot take a fractional items. This can be only solved using dynamic approach, that is problem is subdivided into subproblems and then it can be solved. Whereas fractional knapsack problem, that is here the items are divisible, it can be taken in fractions. The items can be taken, a fraction of an item can also be taken in fractional knapsack. It can be solved using greedy method. So let's see what is a difference between 0 and 1 knapsack. A thief Consider a thief robbing a store finding n items. So here ith item will have worth Vi, that is the value of the item, and Wi, the weight of the item. So here we have W, that is knapsack capacity. The capital W defines the knapsack capacity or the weight of the bag. Wi will represent the weight of an item and Vi will represent the value of the item. We have to take all these three things as integers. And remember that he can carry at most W pounds. In 0/1 knapsack, it is indivisible. He cannot take a fraction of an item with him. So let's see what is fractional knapsack problem is. So here also a thief robbing a store finds n items. Ith item, that is Vi, worth value of item, and Wi represents the weight of the item. So here also there are three integers. One is W, that is the capacity of the knapsack. Wi represents the weight and Vi represents the value of the item. Here he can carry at most W pounds. Note that he can take fractions of items. So how to find the optimal knapsack algorithm. So algorithm is, the input is an integer n and positive values Wi and Vi such that 1 is less than or equal to I, less than or equal to n, and a positive value W, the knapsack capacity. And here the output would be n values of xi such that 0 less than or equal to xi less than or equal to 1, and it will be the maximized profit. So initialization, we have to sort the n objects from large to small based on the ratios Vi divided by Wi. We assume the arrays and store the respective weights and values after sorting. We then initialize array to zeros. Weight is equal to 0 and the iteration value I is equal to 1. So now the algorithm is, while I less than or equal to n and weight less than W, we have to continue. If weight plus W of I is less than or equal to the knapsack capacity, then x of I is equal to 1, else x of I is equal to W minus weight divided by Wi, and weight is equal to weight plus xi into Wi. Iterate the thing again to check whether we have found the optimal knapsack capacity. So here is an example. So when n is equal to 3 and W is equal to 20, values V1, V2, V3, W1, W2, W3 are given. So for this example, the optimal solution would be x1 is equal to 0, x2 is equal to 1 and x3 is equal to 1/2, and the total maximized profit is 31.5. Thank you.